today is about key research fields in energy informatics. It was not easy to say, okay, what would I consider to be the key research field, because as we will see later, energy informatics is an interdisciplinary field, and therefore it's also broad. But I will try to start with some background for energy informatics, also in order to try to put some words on what I see as some key directions that need to be addressed in the future. And some of the background, or some of the factors that are driving this whole transformation we see at the moment in the energy sector, and thereby also have a large influence on our research field in energy informatics, are what is known as the 5 Ds. So it's basically this decarbonization, deregulation, decentralization, democratization, and last but not least, the digitalization. The digitalization is considered to be one of the main means in order for us to be able to realize the first 4 Ds. So if we try to zoom in on all of these Ds, we see a trend that have been going on globally, but in particular a lot in EU, by the change of the regulations, because we had this unbundling of our energy system quite some years ago now, where the EU Parliament decided that power generators and distributors and retailers had to be separated in all European member countries. So there we got the deregulation, which made it possible for many new actors to come in and start to become power generators. So that was the deregulation. It also led to a lot of decentralizations as part of this deregulations, where we saw that we start to have decentralized power plants of various kinds, both fossil fuel based and renewable based. And especially the trend have been that we have got more and more renewable based, and that is also what we know as the decarbonization of the energy system. One of the things we start to see here over the last 5 years is that we see a lot of democratization of the energy system in terms of either private households start to have their own energy systems, and also we see this concept of energy communities, where a group of private house owners might form shared energy communities, where they share photovoltaics or they share wind turbines. But in order then to let all of this come together, we see a need for digitalization in order to capture generation data, capture distribution data, and be able also to have a closer integration with the energy markets, and also be able to handle the billing. So it's all about this transition to the renewable energy. And what I try to show here is related to the Danish energy systems, where we have been focusing a lot of wind and also on biogas and on solar. Solar is coming more and more in recent years. And then we have some access to hydropower through our interconnectors to Norway. So this is the energy mix that within renewable that we are looking into from a Danish perspective. So if we look at what this transition have been of the decentralization over the years, is that I have a very old picture here from 1985, where we see a map of Denmark with very few wind turbines, very few decentralized power plants, and that changed over. You can see the other picture here from 2009, where you can see a much more scattered picture, where you see a lot of decentralized power plants. You see much more wind in terms of land-based wind turbines, and you also see a few wind turbines at sea. Many of these decentralized power plants you see in here is related to industrial production, where many industrial facilities actually have their own combined heat and power plant, and some of those you also see are related to district heating production and also power production. But it's a trend that we see more and more of this decentralization. It have also led to a lot more wind around Denmark, and we are getting more wind in recent years, and all of this is going to be integrated with our high voltage transmission network. So lately we start to have these planning these energy islands around Denmark, where we are going to have one in the North Sea, very big, and also plan to have around Bornholm. So that's just the latest development in increasing the amount of renewable energy in the Danish system. So the goal is to reach 100% renewable energy system over the coming decade. That will be very based on a lot of wind, and we will also see some solar, but there will still be a lot of biomass in it. So what does all of this mean when we try to understand what it will mean for our energy system overall? Well, we have been moving away from the traditional supply chain in the energy sector, where we basically have what we call this one way, where it goes from generation to consumption. So that we have seen with this transformation of the higher integration of renewable energy is that we have ended up in a two-way energy systems, where we both have the traditional generation side, where we have also large wind parks, but we also have an increased production more locally in energy communities and in private households that feeds into the distribution grid that can be sent up in the transmission grid and transported further. But we have challenging a big challenge with all of these renewables, because they're very, very fluctuating, especially when we look at the wind production from or the power production from wind. What I've put in here is the production over a year from the Danish wind turbines, and here we can see that it leads to a lot of fluctuation in the production. That also means that a lot of this fluctuation needs to be balanced. One way we balance a lot of this is with our interconnectors to our neighbor countries and our Nordic Nord Pool market, where we can trade energy with our neighbor countries. But then one of the other things is also that we start to look much more into how can we use flexibility in our energy systems to try to balance it. But the need we see here for balancing is mostly, as I said, due to the fluctuating, which have an influence on our grid stability. But the problem becomes a little bit different when we go down to the distribution grid, where we see more and more integration of renewable, typically in terms of residential household solar. But we also see a much higher electrification of our distribution grid, because we start to have more charging of EVs, and that starts to become a problem for the distribution grid, because it was not built to this strong electrification, so it actually don't have the capacity for it. So that's also where flexibility may play a role in the future. So in order to create better balance of our electricity grids, and in order to make opportunities for harvesting energy flexibility, we need to look at this digitalization across the whole supply chain. And the figure I put in here is a figure I got from the International Energy Agency, who have a lot of interesting reports also about the digitalization of the whole energy supply chain. that focusing on each segment of the supply chain and what are the opportunities to increase the digitalization. So if we look at it, the digitalization and what it would help us to achieve is, for instance, we will gather much more data on the generation side. We'll store them in various kind of cloud solutions that will allow us to make different kinds of applications. It will allow us to make better wind and solar generation forecast. When we look at the transmission grid and the distribution grid, much more data are being collected by different kinds of sensors. All of this can help us to improve and maintain the grid stability and reliability in the future. It can also help us to create better assets management. We will be able to have better prediction of fault and also have prevention of faults by preventive maintenance. And when we go to the generations or the consumption side, we will start to have more data for local generation. We will have more data for consumption, especially with the rollout of smart metering that was completed here last year in Denmark. All of this will allow us to make much better prediction about the demand side, and it will also help us to have better demand side management and allow us to introduce various forms of flexibility at the demand side. If we look at it all together, it will also help us to have better optimization of how do we do energy storage. It might either be energy storage connected with distribution grids, or it might be energy storage at the local consumption side. And at the end, all of this also require new designs of energy markets, something that has also been done a lot of work on local energy markets, and then actually how should we organize the whole energy markets in the future, where it's based on renewable energy with a marginal cost of zero. So what are the technologies that allow us to have this digitalization of the whole energy supply chain? It's basically what we see within many other fields that have been digitalization. It's based a lot on cloud computing, where we can store the data in central databases. It's based a lot on edge computing, where we can do optimization and control local to where the energy is produced or where it's consumed. It's based a lot of the Internet of Things, sensors and actuators that can be distributed and communicated with wirelessly. And then it's also a lot about big data analysis. How can we use all the data that are collected along the supply chain to optimize and make better decisions about when and how to produce and consume. And behind it, we also see a lot of work within AI, especially when it comes to forecasting and decision making, and also based on optimization models. All of this, of course, is based on having internet coverage. So that's one of the reasons why I like to put this picture when we talk about digitalization, because in order for all this data to be collected and be used for analysis and also for control, we need to have a backbone, an internet backbone. And it means that it's only parts of the world who can easily benefit from high integration of renewable energy, because that's where the internet is placed. So it's just something we need to keep in mind, that when we talk about digitalization of the energy system, there also need to be an internet behind it. But at the moment, we can see that where we also have the internet is also the places where we have high internet coverage. In the places where we don't see this tight integration between the energy system and the internet, we often see a lot of focus and work on microgrids that will then just use local area networks.
So energy informatics, how can that succeed? Help us to succeed with the digital transformation of our green energy transition? Well, within energy informatics, we focus a lot on how can we create these digital solutions that can help us to integrate the systems along the energy supply chain. And we have a lot of focus on how the demand side and the distribution side can be closer integrated. But this is not only a technical challenge, it's also very dependent on the regulations, the energy policies that are made by governments, and also on what are the economical incentives for change, and what are the business opportunities for businesses. So this becomes a highly interdisciplinary area in order to consider all the different factors that influence the solutions and the business models for these digital solutions that we can create. I tried at some point to make a model that tried to categorize and organize all of these aspects, and the model I came up with here tried to organize it into a number of layers where we have the society's goals, we have some overarching themes, and we have the whole ecosystem, and then we have some of the academic fields. So if we look at the beginning, one of the things that is a society goal is actually to increase the energy efficiency of all energy consuming sectors. There's also a goal to having more increased green economic growth. That means green jobs and green products. And then, of course, focusing much more on the renewable energy supply in order to reduce the CO2 emission and the greenhouse effect. So that is the goals we have at society level. If we come down and look at what the literature in general have on the research themes, a lot of the research that have been carried out are done within the area of smart energy systems. And this includes both the demand side and the supply side and the integration between them in the smart energy system category. We also have a category that focusing on innovation and business development, economic growth, and that is what we call the smart energy business innovation category. And then we have the smart energy network, and this is basically what lately have been known as sector coupling, where we're focusing on how the electricity grid, district heating and cooling grids, and gas grids can be integrated. Yes, so that was basically the three levels. And when we look at how it goes together in the global perspective of where the energy is being used, we can also see it's very related to where we also saw the internet coverage. So again, here we see there's of course a very close correlation about the electrification and the what we may call it the internetifications. So the role of energy informatics across domains. I try to list some of the domains where we often see these aspects discussed, and it's basically within smart cities, smart grid, smart buildings, smart mobility, smart factories, smart agriculture, and smart energy networks, the sector coupling. Some of these areas, as we will come back to, you might not have seen so much discussion like smart agriculture and also smart factories, but these are two areas where there's actually increased focus in recent years, where the other domains here have a longer story. So if we look at the smart cities, we actually see that in smart cities we have all of the things coming together. We have a lot on the buildings, so that relates to the smart buildings. We have a lot of the energy infrastructures. This is both like the electricity infrastructure, it's the heating or cooling infrastructure, and it's also water supply infrastructure, and they also have all the mobility aspects and transportation aspects. So when in cities, there's a lot of systems that needs to be integrated if we want to utilize or flexibility
in energy production and in consumption, both related to buildings and mobility and commercial sectors and so on and so forth. So the smart grid that includes the cities, but also includes the integration with all the energy production around cities and suburbs, is basically to monitor the production and the consumption. And for the smart buildings, where you will find a lot of literature also, is basically focusing on buildings that are, first of all, constructed to be much more energy efficient, both due to their physical construction, but also due to the way they are optimized and operated, and also with a large integration of renewable energy, typically either as rooftop solar, but we also start to see actually solar being integrated into the building envelope. These buildings then try to optimize the indoor comfort with relation to actually how much the energy they consume. And based on this, we actually are able to integrate buildings with the distribution grid such that buildings actively can contribute to provide demand response services to the distribution grid, either by postponing energy use or lowering energy use or increasing the energy use based on what is the need of the distribution grid. When we have a large cluster of these buildings, we can also integrate them together in what's known as a virtual power plant that can then provide a larger amount of services that can actually be then offered up to the transmission level grid. Mobility is one of the other areas with a lot of focus, both on efficiency, how can we have a more efficient mobility systems, either by various kind of sharing or in the future autonomous cars, and optimize how people are transported in order to use less energy, but it's also closely related to the integration with the electricity grid when it comes to smart charging. How can we optimize the charging of a fleet of electrical vehicles such that we minimize the load on the distribution grid. Factories, as I mentioned before, gain a lot of attention, both in order to reduce the electricity and energy consumption in general, but also to see how it can become possible to integrate a larger part of our production factories with the grid in order to provide various kinds of demand response services. And this is really something that is non-trivial, because this has to be done without jeopardizing the product quality or process quality. So this actually requires a lot of new knowledge about the industrial processes. It also requires a lot of modeling of processes that have not been done but needs to be done. So this is an area where I foresee that in the next 5 to 10 years they need a lot more work on modeling industrial processes in order to allow us to be able to control them and thereby integrate them with the energy networks. We see similar in agriculture, where there is work being done on optimizing greenhouse production, the energy consumption in greenhouse production, also optimizing in relation to how we handle agricultural products from the fields all the way through the supply chain to end consumers, in order to minimize the CO2 footprints and the amount of energy used from field to table, so to speak. And the last I have here is about the sector coupling, where we have a lot of focusing on how can we integrate the electricity produced by renewables either into to synthetic gas that can be used in our gas grid and thereby also stored, where it can and how it can be used directly in the heating, either through heat pumps or going to district heating power plants. So the sector coupling here is about optimizing the production and use of energy across these three sectors. And this can then again be integrated with the demand side, with smart factories or smart buildings that can also provide flexibility into the sector coupled system, which again leads us back to the smart cities, where actually everything needs to be orchestrated. Good. I think this gives us time for some questions, if anyone